everyone, this is Mrs. Snook with section 5.3. And 5.3 is about two kinds of bisectors in triangles. It's about perpendicular bisectors and angle bisectors. So it's similar to what we did in 5.2 where we looked at those two types of bisectors. The difference is this time we're going to look at where those bisectors meet. And where they meet is a point of concurrency, which means a place where more than one line segment meets, called a point of concurrency. And they actually form what we call centers in a triangle. There are 4 centers in a triangle. We will do 2 of those today. The first one is called the circumcenter, and that's formed where your perpendicular bisectors meet. So perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. So if you look at our picture over here, I'm going to highlight the perpendicular bisectors, and all 3 of them are meeting at the same point there. So that is the circumcenter. The circumcenter is always equidistant from the vertices of the triangle. So what that means is the distance from the center to B is the same as the distance from the center to this vertex and to this vertex. Since it's all the same, what you can do is you can take a compass, and if you put the point of your compass right here on the circumcenter, open the length to be the same thing as this, then you can actually draw a circle, a perfect circle that goes around that triangle. And my circle is not so perfect, but I hope you get the idea. So what we're going to do now is we're going to list all the perpendicular bisectors. So we have line segment PD, line segment PE, and line segment PF. Those are all the perpendicular bisectors. They meet at the point P, so that's your circumcenter. And then we're going to list all the congruent segments. Well, let's list the interesting ones first, the ones that make the radii of our circle. So we have line segment BP is congruent to line segment AP is congruent to line segment EP. Those are all the same. Not EP, sorry, CP. Let's fix that, CP. And then the sides that get bisected, they're going to be congruent to each other as well. So BD is going to be congruent to DA, and AF is going to be congruent to FC, and BE is going to be congruent to EC. All right, so let's do some practice with this. So if Z, right here, point Z, is your circumcenter of triangle TUV, we're going to find each missing measure, and these are going to be lengths. First one is TU. Well, that's this length going all the way across. I know this is 19, so for this has to be 19. All the way across is 19 plus 19, or 38. VY, that's this one right here. Now we are given VU, which is 34, so half of that is going to be VY, and that is 17. So this is 17, this is 17. UZ, that's the length of one of these radii for your circle, and we are given that length right here on this one. They're all the same length, all 3 of those bisectors, so therefore this one is going to be 21. Next, it asks you for WZ, and I am going to highlight WZ for you so we can see it. There's WZ, and that goes, that's just the perpendicular bisector, and it wants the, sorry, not WZ, WV. Right here, I want this piece. So that's half of one of our sides. Now, I'm not given that whole length, but what I do know is that this is 15 and that's 21. I also know that this is perpendicular. So if you think way back when, you learned Pythagorean theorem. And we will see this again in chapter 8. Actually, I think chapter 7. No, chapter 8. We'll see this again in chapter 8, but just a reminder, this says that your hypotenuse squared equals the sum of the squares of the other sides. So I want WV, that's not a hypotenuse, 21 is the hypotenuse. So 21 goes in here. One of my sides is 15, so 15 goes here. And WV is what I'm looking for, and that's another side. So that goes like that. So when I plug in, I'm going to then subtract 15 squared from both sides. So when I do, WV squared is going to be 21 squared minus 15 squared. Go ahead and punch that in your calculator. 21 squared minus 15 squared. I get 216. So WV equals 216. Take the square root of that. So WV equals, I'm just going to punch my square root button. And I get 14.7. So WV is 14.7. And then it wants TV. Well, WV is halfway across. So TV is going to be twice that. So we're just going to take our answer and multiply it by 2. And I get 29.4. Okay, so that is circumcenter for you. We're going to come over here. We're going to do the incenter next. Incenter is also a point of concurrency, but this time it's the angle bisectors. And you use those for all the angles of the triangle, and they're going to intersect at a point called the incenter right here. So check this out. Line segment BP is an angle bisector. Line segment CP, angle bisector. We know this because of the way these are marked. AP, angle bisector. They all converge in the same place. That's point P. And then we have another interesting thing. This incenter here is always equidistant from these sides right here. And these not only are perpendicular, but they're also going to cut these in half. So what happens is you have another circle, and the incenter is always equidistant from the sides of the triangle. So you see that again, my circle is not the greatest, but I hope you get the idea. So each of these lengths, PD, PE, and PF, they're all going to be the same, and they make the radius of a circle that perfectly matches the inside of your triangle. And that's why it's called the incenter, because this circle is inscribed. It is inside the triangle. So we're going to list our angle bisectors here. First angle bisector is BP. Our second angle bisector is going to be CP. And our third angle bisector is going to be AP. Incenter of this one is point P. And now we're going to name all of our congruent segments. Right away, we know that those radii are going to be the same. So DP is going to be congruent to EP, which will be congruent to FP. We have some more segments that are congruent, and I want you to check this out. Think back to chapter 4 when we had different kinds of triangles, and we were looking at whether they were congruent or not. So take a look at this. I have a triangle, I have two triangles right here. Here's one in the yellow. Here's the other in the green. Notice we have a reflexive with AP. So AP is congruent with itself. I also have PD congruent with PF, and I have right angles in here. So this is hypotenuse leg. That means that my yellow triangle and my green triangle are congruent. So I know that line segment AD is going to be congruent with line segment AF. And the same thing works going around our large triangle. So BD is going to be congruent to BE, and EC is going to be congruent to FC. So let's do some practice with this. If P is the incenter of triangle JKL, find each missing measure. So here's our incenter. We know NP is going to be the same length as MP, so that's 8. We know NK, this is 8 here. We're looking for NK, so let me highlight this. Here's NK. That's going to be the same as KO. So that's 17. Next it wants PK. So it wants this one. Interesting thing, we know NK is 17. I'm trying to get my pen to work. Every time I tap the pen, it doesn't actually get it. Let's try it again. That's 17. And we know that NP is 8. So there's our right triangle again. This time they're both legs. So PK is going to be 8 squared plus 17 squared. That's going to be PK squared. So PK squared equals, just punch this in your calculator, 8 squared plus 17 squared. And we get 353. Square root of that. I'm just going to press my square root button, and I get 18.8. And then it wants us to find LO. So let's take a look at that one. This one I know is 13. Okay. LO is what I'm looking for, so I'm going to put a little question mark there. And I know that PO is the same as NP, so that is 8. So I can do the Pythagorean theorem game again. And I can say that, I'm going to write it over here on the side. I can say that 13 squared equals 8 squared plus that LO squared that I'm looking for. So 13 squared minus 8 squared, I get 105 equals LO squared. And then take the square root, and you get 10.2. All right, so that is a circumcenter and incenter. That's it for today's video. Thank you for watching, and have yourself a great day.